Don't tase me, bro. That's right.
You're good.
Okay, we're good here. All right. Well, thanks for showing up, everybody. Got a few things here. If you're interested in the satellites and some other stuff, we got some freebies up here. You can pick them up after the show, and we're all set. We're gonna get recorded and everything. All right, very good. And wanted to let everybody know it's free to get in, but $5 to get out. So. Okay. Oh, I can use this as my laser pointer here. This will be good. Okay, that sounds good. Okay. All right. I just finished writing a book over the course of the last year called Grounding and Bonding for the Radio Amateur, and it started out as part of, as a consequence, I guess, better thing. A consequence of doing some columns at the beginning of 2016, hands-on radio, about one called The Myth of RF Ground. And it started generating a lot of correspondence, and I did a couple more columns on the same topic, and it generated more conversations and emails and back and forth than in any of the 15 years that I've been doing that column. So I said, we really need a book on this to pull all of the information that's out there into one volume, because it's spread out. There's stuff on safety, there's stuff on lightning protection, there's stuff on RF management, current and chokes and voltages and RFI and all this kind of stuff, but it's all over the place. So how does a person go about finding what they need when they're starting to build a station or they're upgrading a station, whatever? So I brought all this stuff together in one book. It's been well received, and the point of this talk tonight is to sort of give you a 30,000-foot overview of grounding and bonding. And when I say for the little pistol and the medium gun, talking about small station owners, people who are building a small station into a larger one. For those of you who are technicians and you just got your license, or you've been operating on VHF for a while, you're thinking about HF, this is something that you can start thinking about now. It also applies at field day, also applies in portable mobile operations. So the point is, you don't have to memorize all this stuff. I'm trying to put some general ideas in your head tonight. Okay, so the talk is going to go, what is ground? We all think we know what ground is, but everybody's got a slightly different understanding of it. What is bonding? Sounds expensive. We're going to talk about AC safety, lightning protection, RF management. I call it RF management because what you're really trying to do is deal with the currents and the voltages that you pick up in your station, as opposed to trying to make them all go away. That's kind of impossible, so how do we deal with it? So we're going to manage them, not necessarily try to ground them or suppress them or whatever. I'm going to talk about your ground system and point out some resources for you. At the end of this session, and I gave this to the Contest University in Dayton, at the end of and they have lots of different sessions. At the end of this session, what I hope is that you'll understand the difference between the word ground and bond, and appreciate some of the different requirements that you have for these different things that you do with your ground system. The AC safety, the lightning protection, and the RF management, and audio, which is also important if you operate digital modes or something like that. You want to deal with keeping your audio nice and clean too. So we'll show some techniques. This is not a cookbook. There is no cookbook out there that if you follow steps 1 through 3 and then 4A and 7B through 10C, you'll have a perfect ground system. Basically, you get a toolbox and some requirements for how you use the tools, and then you have to build it up depending on your personal circumstances. So I'm going to show you how a system approach works to designing your ground system. And then I'll point you at some more comprehensive resources, because you'll have lots of follow-up questions. And so what I'm going to do is point you at some resources you can get your hands on, so that when you have specific questions, you can go find the answers. So who's this for? We just started talking about, if you're just starting out, that's actually the best time for this, because you don't have all your stuff in place. You don't have everything screwed down. You don't have the wires and the cables and all this kind of stuff. The easiest time to do grounding and bonding is when you're starting. So if you're just starting out, this is perfect. If you're putting up a first tower, you're going from a wire antenna to, say you're going to put up a small tower in the backyard or something, and you're worried about grounding and bonding that tower. What if you're expanding your station? Everybody starts out with small stations and boxes on the desktop, and then you get some more boxes, and you get some more boxes, and what do? What if you live in Lightning Country? Hey, we're in Lightning Country. How about that? I live in St. Charles County, but I have a station down in Steelville. It's on a ridge top, and I call it the Crawford County Cumulonimbus Discharge Facility. There's trees have been hit. I know the towers have been hit, all sorts of things. I've blown up the phone a couple of times, a couple of rotator control boxes. And if you're just trying for better performance at your station. But it's not really for the big guns. We've got a couple of big guns here in the room, and they've got different problems than most people have. They have big towers, like Tim Duffy's got 6 towers, the tallest of which is 240 feet tall and has lights on it. So he's not your typical ham. So I'm not talking about the big gun guys, I'm talking about the little stations. Here's your background references. The ARL handbook and the antenna book have good information in them. I've updated the grounding and bonding stuff for the next edition that's coming out. The ARL antenna book has a good section on building antenna systems. The new book is Grounding and Bonding for the Radio Amateur. Anybody bring a copy tonight? Yeah, a couple people. Okay.
I want to thank you for putting it digital.
And it's in digital too, and Kindle.
That's the nice thing about it, because before we couldn't get anything in digital, and I don't have space on my shelf. So
Yep.
I have all of your learning books from.
There you go. I tell you, it's talk about the East Coast sinking into the sea from the weight of all the old handbooks that people have collected. Yeah, so you can get this. This is available in Kindle form. The NEC handbook, that's not a book to go out and buy. It's a couple $100 if you buy a new one, but it's at your library. This is a good book. You can go copy the applicable articles. The chapters are called articles, and keep them at home. This is free, Standards and Guidelines for Communication Sites. It's put out by Motorola for their communications facilities. And of course, you look at it and you go, well, I can't do that exactly, but they give you some guidelines on what you can do. So if you got $1 million, of course, you can follow the standards. But if you don't, you can see what they do and do your best. Lightning Protection for the Amateur Station was a series of articles in QST in 2002 by Ron Block, who was one of the Polyphaser founders with his brother, and it's very good. These are free. They're on the ARL website. Google is your friend. Just type it in. And Jim Brown, K9YC, has put out a lot of good information. This is a very good pair of talks, and they're on his website right here along with a bunch of other stuff. Power, Grounding, and Bonding and Audio for Amateur Radio is a PowerPoint presentation, and RFI ferrites and common mode chokes for hams is a PDF document. All good stuff. Here's what the Grounding and Bonding book looks like. Here's what the NEC handbook looks like. If you just get the NEC, the National Electrical Code, what you get is a list of code element text bits, and it's not all that helpful. What you want is this handbook version, which is nice and thick. It gives you pictures and explanations and rationale, and it can be pretty dense. Even electricians have trouble with it every once in a while, but it's a good reference to have, and this is the Motorola standard right here. So let's talk about what is ground anyway. And the right answer to this question, if somebody says, what is ground? It depends on what you're trying to do. I used to be a datacom engineer at a big medical company, and I had a business card size thing in my pocket that said, it depends, because everybody would ask me a question, and the first, it was always, it depends. It depends on what you're trying to do, what you're trying to accomplish. And so are we talking about AC safety? Are we talking about RF? Are we talking about lightning? What? So you have to have this big view of what ground is before you can really get the right answer. What you're trying to do depends on the frequency, the voltage, and the current. We'll talk about AC safety. AC 60 hertz, 50 hertz. The wavelength is what? 50,000 miles or some ridiculous 50,000 meters. It's really long. So when you talk about something being electrically short at 60 hertz, it can be the size of a football field and be electrically very small. If you're talking about 2 meters, electrically small means a couple of inches. So the frequency matters. how much voltage are we talking about? Are we talking about 20 volts? Are we talking about 5 millivolts? Are we talking about 6 kV? Or what? And current varies all over. Leakage current from capacitors inside a filter can be a few milliamps at 60 hertz. Current from a lightning strike, even an incidental one, could be in the hundreds of amps. And a big strike has kiloamps in it. So there's quite a range there. So we have to understand that ground, the word ground, applies to some very diverse phenomena. Your safety depends on the right answer in your shack. You want your shack to be safe. It's not a big risk. Most of us go through life. We throw our radio gear at a desktop, we hook it up, we make some contacts, we're happy. It's not a real risky thing, but you do want to be safe. So you want to follow some basic rules. They're not expensive, but if you know what they are and follow them, you'll be better off. Your equipment depends on the right answer. If you live out here in lightning country and lightning hits the pine tree in the backyard, it might induce a fairly large secondary strike or surge in your station, and all sorts of things can pop. I have a TS590, and the little audio USB codec is well known to be fragile, and I left it plugged in one day and there was a lightning strike and it didn't work anymore. I had to replace that board. The USB to serial part works fine, but the little chip in their consumer type devices are just not very robust. So you want to protect those things, and as we get more complex and get more digital stuff at our stations, this is an important question to ask, is am I protecting my equipment? And your sanity depends on the right answer. You can chase your tail for months and weeks if you don't have a good grasp of what you're trying to do and you're trying to solve an RFI problem, or maybe you've got a buzz problem in your audio or something. If you don't understand the fundamentals of what you're dealing with, it's just by luck and by golly that you solve it or you don't. And so the more you know about the problem, the better off you're going to be and the quicker it's going to be to solving it. So let's talk about ground. Ground can be a noun, a verb, and an adjective all at the same time. At this medical company, I used to have conversations with people, and I would listen to them talk to each other using words, and they thought they were having a great conversation, and I realized that they were using the same word to mean two wildly different things. And so I had to step in and say, no, you're using the word record, and you're using the word record, and they're quite different things in your world. So let's get this straightened out. So ground is a particularly obnoxious word. We use it to apply to everything. And it's an earth connection. Here's your noun, a connection to the earth. And actually, the English call it an earthing connection. And that's when you're talking about AC or lightning, you want to talk about an earth connection when you talk about ground. It can be just a local reference potential. When we talk about ground in a circuit or ground for a transmitter or an antenna, we're just talking about a local reference potential or voltage. It can be a verb. You can ground something, where I'm going to ground this connection. I'm going to ground this power supply. I'm going to ground this antenna. So it's an action, which means to connect something to the reference potential. It can also be an adjective, which is a type of connection, such as a ground conductor or a ground system. So when you talk about, and we use this word to mean so many things, you just need to be aware that it can be confusing when you read it or when you're talking about it. So know what you're talking about and have a clear concept of what you're trying to accomplish with the ground. There are some fuzzy definitions. Been around for a while, you hear this term RF ground. Well, there ain't no such thing as an RF ground. All you're really talking about there is trying to get everything to the same voltage. Okay? You're just trying to get it all to the same voltage so that if you have the same voltage over here and over here, then RF current doesn't want to flow between those 2 points. And the RF current flowing between those 2 points is what causes the problem. And that's what causes hotspots. That's what causes RFI. That's what causes RF feedback. It causes all sorts of bad things. So you can't just connect something to the earth and expect all the RF current to go, oh, it's the earth, I must go there. Zoop, and it goes down to the earth and everything's at 0 volts. There is no such thing as 0 volts when you get to RF. There's only a local reference that you've got. If you talk to guys that work with high power RF and you're walking around in a facility or over the ground field, you can get hundreds of volts just between different points in the ground, just because of the current and the wavelength and the frequency and all that sort of stuff. So to stop using the term, talk about RF management, talk about a ground plane, as we'll see later. Ground loops, they're not the problem that you think they are. Every time you got hum or buzz, somebody will get on the air and say, well, you got a ground loop. Well, you probably don't have a ground loop. What you probably have is potential differences in your station that are causing current to flow. Now, ground loop, the definition of ground loop is some connection of ground conductors that makes a complete loop. When you make a complete loop like that, if there's a changing magnetic field, like from a power transformer, it will induce a voltage in that loop. And that's how generators work. So if you've got a loop and you've got a magnetic field that's changing, you're going to get a small voltage in there. It can be a big voltage if it's a big magnetic field. But generally, this is not a problem for hams. If you look at the back of a station, you look at your equipment, you'll see dozens of ground loops. You got all your cables connected on there, and the shield goes through the back of the radio, and there's another shield, and it goes to another radio where it's screwed onto that, and that goes to an antenna switch, which connects back to the first one. You've got a ground loop, okay? So there are dozens, literally dozens, maybe hundreds of ground loops in a typical ham station. You're never going to get rid of them all. All you can do is manage the effect of having all those conductors out there. Don't worry so much about ground loops. If you've got a 60 cycle hum, not a buzz, but a hum, and it moves, if you move the wires around, or if you move the equipment around, and the tone or the amplitude of that changes, you might be picking up a magnetic field. Move it away from the power transformer or whatever is causing it, like a motor on a fan, but these are really not very common. Single point ground, this is another fuzzy definition. Single point, remember we talked about the wavelength of 60 cycle power being 50,000 meters or whatever it is, 300 times 10 to the 8th divided by 60, whatever that is. It's a lot, okay? 50 million meters. So things can be really large and still be electrically very small. That's what single point means. It means small electrically, so you can ignore the size of it. So AC, the electricians, they're fine with running a big long cable from over here, down to the circuit breaker box, and calling that a single point ground, and running ground cables all over the place. That's a single point ground for them. We could have a shack in this room and run all of our power cables to one point, call it a single point ground. That'd be fine for AC. It might even be fine for lightning. Lightning is a low frequency event that goes from DC all the way up to a megahertz or 10 megahertz or more. Most of the significant energy is under 1 megahertz, okay? So 1 megahertz, 300 meter wavelength, stuff can still be pretty big and still be considered single point. But when you start talking about 20 meters, 6 meters, 2 meters, 23 centimeters, single point gets smaller and smaller and smaller. So if you're going to use the term single point ground, realize that you've got to know what your wavelength is when you're talking about it. So if you're talking about DC or AC type single point ground, it's a big difference than lightning, and it's a big difference than RF, and we'll talk more about that later. But remember, just a connection to the earth is not a magic sink into which we can pour RF current and have it go away. What is bonding? Now, bonding sounds expensive. Sounds like something you do to get out of jail. Okay, well, it is, but that's not what we're talking about. So it's a connection that's intended to keep 2 points at the same voltage. That's all it is. It can be done with a little tiny wire inside an IC. Bonding is done with little tiny wires that are smaller than a human hair. For lightning, bonding is done with cables the size of your thumb. Okay? It sounds expensive, but it's not. You can use number 12, number 14, flashing, some strap, whatever. to connect your equipment together. You're just trying to connect it all together so that when RF comes into the station, or a lightning pulse or transient or something like that comes into your station, it sees it as one giant electrical thing that's all connected together. So it doesn't pick out one piece of equipment and say, I'm going to go there. You want it all to come up and all to go down at the same time. It's like a floating dock. How many people have a boat? Yeah, no boaters here? Okay. Okay. All right. Used to. If you ever go out and you see a floating dock, why is the dock floating? It's so that when the wave comes in off the lake, everything comes up together and it goes down together. If you try to tie that dock down, what happens is the boats go up and they come down and they tear themselves loose from the dock and all sorts of bad things happen. By letting it float, it comes up together and goes down together. And that's what bonding does for you. It just ties it all together so everything comes up and down together. That's what does the damage from lightning, and that's what causes RFI, is not having everything at the same voltage. That's not the only thing that causes RFI, but when you have pieces of equipment at different voltages and that current wants to flow between them, you can have RFI. Is it hard? No, it's not hard. All you have to do is connect the ground screw on the enclosure or the back of the radio and connect it to your other pieces of equipment. We'll talk about some techniques for that. It does require the right connecting materials and the hardware, particularly for AC safety and lightning protection. And that's why the NEC handbook and the ground references that I talked about say specifically certain sizes of wire, certain types of clamps, certain techniques. Follow them. They're not that expensive. You just have to understand what they are and then do that. And that you can take advantage of the thousands and thousands of hours of engineering time that's gone into figuring out what really works. So if you follow these directions to do your grounding and bonding properly, you'll be much better off. You'll have a very robust system. You'll get better results than if you just wing it. So doing this bonding stuff, the benefit that you get out of this is it works in your favor for all three of those different needs that we talked about: AC safety, lightning protection, and RF management. You don't have to connect, you don't have to create three different ground systems: an AC power ground system, and a lightning protection ground system, and an RF ground system. Make them all one system. They'll work for all three purposes. You only have to do it once. For bonding to work, for this connection between pieces of equipment to work properly, it has to be low impedance and it has to be electrically short at the frequencies of interest. Okay? If we're talking about a 2-meter station, what's the wavelength? Well, 2 meters. Okay, so you want to keep all of your connections less than a 1/10 or a 20th of a wavelength long. So that's pretty short. If you're talking about HF, they can be longer. If you're talking about AC, they can be quite long. But they have to be short and low impedance so that when the connection between pieces of equipment is made, it doesn't look like an inductor. It doesn't look like an antenna. It doesn't look like a transmission line. It looks like a short circuit. And by keeping things short and low impedance, that makes them a short circuit. That's what you want. They need to be heavy enough to carry the expected current. If we're just talking about an op-amp circuit, you may be able to use number 20 hookup wire, something like that, just little clip leads. That might be fine. If we're talking about something that's going to carry maybe part of a lightning strike, if your tower gets hit by lightning, you need a much heavier conductor. You can see online, there's all sorts of interesting YouTube videos of what happens to conductors when lightning-sized current pulse hits them. And those conductors will move, and they'll flap around. The amount of force per foot can be hundreds of pounds if you're talking about a kiloamp size pulse. That's why they require you to tie that conductor down, attach it to your framework or your foundation or whatever. It's because there's a lot of force involved. And so it has to be heavy enough to take that current without melting. And this is lightning protection. This is not RF management. This is not the AC safety part. For RF management, you typically don't have very high currents. For AC safety, it just has to be heavy enough to trip your breakers. If there's a fault, if there's a short circuit, the ground conductor is there to trip the current protective devices, your breakers. And it has to be sturdy enough to survive the environment. I didn't get this at first. It was like, why do I have to buy number 6 AWG copper and these Studley connectors and all this kind of stuff? And then I realized they're there to protect the wiring when you bury it or when you run it around your house or something. It's so that when you dig it up or you back into it or something snags it, it's heavy enough to stay connected. Otherwise, if you just run number 12 around, it may work from an electrical standpoint, but the first time you go out there with the roto-rooter or your rototiller in the spring and you dig it up, it's going to yank it right out of the ground. It's going to break the wire, and you won't even know that you broke it until later when you discover your ground system's not working and something got popped, okay? So it has to be sturdy enough to survive where you install it. Inside your shack, it doesn't have to be number 6. Outside, buried in the ground, it does. So inside your ham station, what I recommend is use strap, 20 gauge copper. You can buy it online. You can buy flashing and cut up strips, whatever, or heavy wire, number 14 or larger. That's compliant with the NEC. Works good. You can use THHN that you get from Home Depot, whatever. You can take it out of the Romex, spare Romex stuff. That's a tip for you. You're going out to the Ham Fest. The best bargains at the Ham Fest are under the table. Okay, look under the table for those guys with those boxes of wire and say, $5, take it all. Offer them $2 and take it all. Okay, it's a great deal. You can never have too much wire. All right, strap or heavy wire, flat weave braid, the kind of stuff that you buy that goes in automotive. It has to be the flat weave tin stuff, not the stuff that you pull out of old coax cable. Once you pull the coax braid off, okay, you loosen it up, you get it out of that jacket, and it's shiny, it looks great, it's got lots of copper in it. What happens is every one of those little strands starts to loosen up. That braid is put on there, and it's put on there tight, and then the jacket holds it together. And the jacket holds all of those little wires together, so they make good contact, protects them from oxygen and corrosive gases, and it protects them from water. The minute you take it out of that jacket, all that protection goes away, all of that compression goes away, and those wires just start loosening up. And after a while, it doesn't look like braid much anymore. It doesn't look like the nice, substantial contact that you thought. If you've got old coax and you want to use it as grounding connector, leave it in the jacket and just take it out, strip it off, make a pigtail of it, and use it that way. That's fine. But the best thing is use flat weave braid. Never use braid where it can get wet. It'll wake up that water just like nobody's business, and once you get water in braid, it's toast. Okay, so only use the braid where you need vibration or you need to move the equipment frequently. Otherwise, use strap or heavy wire. That's the standard. Safety first. Okay, don't be the one that everybody goes, boy, that's too bad about him. You know, he had no idea. Yeah, he was there for days. Yeah, we kind of smelled him cooking. Nope, you don't want to be that guy. Okay, so safety first. Everybody wants to take shortcuts. I'm no different. It's like you're in a hurry, but it's not a race. Know what you need to do what you need to do, follow the basic safety rules. There are expensive ways to do it, there are inexpensive ways to do it, there are faster ways to do it and slower ways to do it, but do it, okay? And AHJ, that's the authority having jurisdiction, and that might be your city building department, might be the county building department, might be your landlord, whatever. Anyway, the authority having jurisdiction sets the rules for wiring AC and light and protection in your residence, and the local code is the law. Don't argue with them about what the NEC says. Local code is the law. Sometimes variations from the NEC are written into local code. Sometimes you go to local code and it says, follow the NEC. Okay. Other times you go and there are variations. If you have questions, talk to an electrician. Find a building inspector. Ask them. Particularly in grounding, different types of soils, different type of geology, different type of local installations and grids have different requirements. If you are unsure, ask. There's lots of resources out there for you. I talk about the Crawford County station. Crawford County has 0 requirements. They don't have any code. You can do anything you want. The only thing you cannot do is poop directly into the stream. Okay? That's it. You can dig a hole in the ground. You know, I believe the polite term for that is a lagoon. Okay, that's it. They'll write you a letter. So we have no building code. You can do anything you want down here. That also means my neighbor could set up international nuclear waste and swine waste reprocessing, and I would have nothing to say about it. But I follow the NEC. But if I live up here, if I'm doing some work in St. Charles, local code. And it can be expensive not to know what the local code is. And you get your concrete poured and blah, 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 and the building inspector comes in and says, sorry, you didn't have me check that out, or I can't verify that you follow the rules. You got to take it out. That's a big, big mistake. If you're not sure what you're doing, and I know all of us that carry the Y chromosome always know what we're doing, okay? But if you have a friend that doesn't know what they're doing, okay, this is a great little book. This is sold at, I think it's sold at Home Depot. You can get it at Amazon. It's $20. And it covers everything. It covers 4-wire, 220. It covers installing a washer and a dryer and gas stuff and building something new and everything. It's a terrific book, $20. Or hire a professional electrician and do it before the fire, okay? AC safety grounding. It has several different names depending on who you're talking to. Around the country, you'll find different ways of referring to this. Equipment ground is one way of referring to it. The 3rd wire ground or green wire ground. That is the AC safety ground. And it has 2 purposes and 2 purposes only. It doesn't know about your RF. It doesn't care about your RF. Its job is to provide a path back to this AC common point, usually in your circuit breaker box at your home, for fault currents, either from short circuits inside a piece of equipment or for leakage current. Sometimes insulation breaks down, and you want those currents to go back to a safe point, not through you. So when you're walking around on one of these 110-degree days and in bare feet in the basement and you touch something metal, you don't want to complete that circuit. You don't want to become part of the circuit. You would really rather not. So you want it to go back to this AC common point. And the other thing that it does is it stabilizes your AC power voltage during faults or transients, such as a lightning strike on the power grid, or perhaps a branch falls down and does a phase fault, or something happens and there's a big fault in the power system someplace. Big transients can come rocketing down the line. So all these little pole grounds and the grounds at each house, all they do is they try to stabilize that voltage so that half of the system doesn't go to 3 kV for half a second. So that's the twofold reason to have AC safety grounding. Here's what it looks like. Here's your utility transformer. There may be a ground wire at your pole or on this little section of poles. This is usually what politely referred to as a butt wrap. You see the wooden pole that comes down, it has a copper wire on it, and that goes into the ground. They wrap the butt end of the pole and they put it in the hole and they fill it in. They call that a ground. It's not a very good ground, but there are zillions of them on all the different poles. So that's one of the stabilizing ground conductors. Then you have 2 phases that come in. If you've got recent service, you'll have a main breaker, and that goes to the rows of contacts in your circuit breaker box. What we care about here is this connection, the neutral. And so you get two phases that are out of phase with each other. You get 120 volts, and if you looked at the waveforms, they'd be going like this, okay? So if you connect something between here and here, you get 120 volts. If you connect something between here and here, you get 120 volts. But if you get something between here and here, you get 240. Okay, the neutral comes in, it goes to a neutral bus, okay? And you'll see all the neutral wires, the white wires of your branch circuits come back and they tie to the neutral bus. And then there's a jumper called the main bonding jumper. And it goes over here to this separate bus where all the bare wires go. And so that's the grounding bus. So this is also tied directly to the metal enclosure, and that's supposed to go to the grounding electrode for your service entry. And that can be 1 or 2 ground rods. It's supposed to be outside the house. This is what safety grounding connects to, right here. This is the stuff. That's the common point. Yeah?
When did they put that ground to the outside? When did that start? That a newer thing that like a house that's built in the 30s has that? Or?
If you go down to your, you live in St. Louis County? Okay. If you go downstairs or wherever your circuit breaker box is, find the big wire coming off your grounding bus, follow it. It'll go outside through the wall, and it should go directly to ground rod, right outside.
When did they start doing it?
Yeah.
Oh,
Do that at my house. Goes to the meter.
years and years ago. But I think in the 40s and 50s and 60s, and maybe not. I don't know. If you don't have one, you should. Okay, so you might want to call an electrician and have him find it. It's not hard to put one in. I'm going to be installing one. Crawford County, they don't care, you know. I asked my electrician, I said, what happens if I put in some more ground rods? He says, can't never have too many grounds. So, all right, I'm going to put in some. All you got to do is drill a hole through the blocking and run a piece of number 6 from your ground right here. There's probably a big terminal right on your service box. Run it right outside, right to the ground rod, a few feet away. Right. Here we go. Here's yeah. Question. Yeah, Bill.
Our house is 40 years old. It's in the county, and it was bonded by cold water pipe.
Oh, cold water pipes.
Same with mine.
Okay.
Mine was done in the 90s.
Cold water pipes work if they are metallic all the way back to the main. Okay, there's a lot of new construction that uses plastic, and there's a lot of rebuilt water main stuff that you've got a plastic main, and then you've got a plastic service, and it comes up and it transitions to your metal for older houses. This is very common, and so it looks like a metal ground going out through your basement wall. If you dug it up, you'd find a foot or two out there, it changes to PVC. So unless you are absolutely certain that you've got copper going all the way to the main, don't count on that cold water pipe as ground, or run an auxiliary ground. Yeah,
I had
Tom.
the same situation, and I had to repaint and pull my meter base, and I had to disconnect. So when they came in and inspected, I had to bring it up to current code and put a driven ground rod in.
Okay, yeah, anytime you have rework on your meters, and the gas people will require this too, they will bring your grounding system up to code. And that book that I referenced shows how to ground appliances and different piping together in your house and what not to do. Don't use your gas piping as your primary ground either. Yeah. Or we'll be reading about you. That's right.
I'm in the county now. Mine was all inspected when they did it, and it was in the early 2000s. It's got a solid copper wire that runs from the meter on the outside of the building
Yep.
to the ground rod right there in
Yes.
the ground.
Yes.
But then they've got from the ground bus, it runs up to the cold water pipe in the front, and it is metal
Yeah.
all the way.
Okay.
But
Well.
I'm confused why they have that ground rod, but they didn't actually bond to that ground rod from the panel.
That's an excellent question to ask them. That may be a not my job answer. That may be just the point that their job ended here and the inside guy's job ended here, and nobody bothered to connect them together. But your entire ground system should must be bonded together. And it won't hurt anything for you to go and add extra bonding. If it makes you nervous not to see a wire there, and it's between two ground points, go ahead and put a wire there. Won't hurt it. Okay? And talk to your electrician guys about this. Okay? Oh, I was about to talk about that, wasn't I? Let's see. There's got to be a page up. Yes, there we go. Okay, when you put in your ground rods, the spec now is 2 ground rods, not less than 6 feet apart. They typically want you to space them at least as far apart as they are deep in the ground. Okay, so if you got an 8-foot ground rod, you put them 8 feet across. This is your piece of number 6, okay, and use these clamps. No hose clamps, no soldering. Use the real stuff. This is not expensive. It's at the store. This is an Acorn clamp, and this is a GC style ground clamp, and if you look carefully, you can see it's got a little hole there for you to connect a ground wire to it. These are not expensive, and you can actually bury them. You run the wire, you pound these things down into about 3 inches of the ground, you run the wire over there, put the clamps on, and then pound them on down into the ground.
Yeah, they should be stamped DB, direct burial.
Yes, they have to be listed as direct burial clamps. Not all of them are, but there are direct burial clamps that are rated for that service. Or you can use one-shots, which we'll talk about in a little bit.
Just going to ask if you like using Oxyband.
I love it.
Okay.
It's a lot of fun.
It will. Yeah.
Okay. We'll talk about it right now. You can see that right here. If you look over here, down here, you can see this little crusty looking thing. That's what's left after you use a one-shot. The one-shot is a thermite welded thing. It's a powder. You get a little crucible. You put it on your ground rod. You put the ground wires in from either side. There's lots of different variations on it. CAD weld. And then you put the starting powder in there, and you spark it, or you use a sparkler, and you stand back. As they say, place on ground, light fuse, retire quickly. It happens like that. And I thought KF7P has a really nice video of using one of these things on the internet. And I thought, oh, that's got to be really sped up there. And then I went and set one off. And no, it's like 1 second, and you got a 2,000-degree blob of molten metal in there. And so what you wind up with is everything all melted together, and you break off the crucible, and you never have to worry about it ever again.
Kind of like bronze.
Bronze, yeah. Bronze, copper, whatever. It's hot. But it's fun, kind of neat. Sparklers work good. Set it off.
You want to drive it in most of the way before you do that.
Yes, if you're going to bury it, you don't want to be beating on it after you've done the weld. So get it in the final position. That particular item was in a trench. And I'm not sure you can really see it. Well, you can see the typical Missouri dirt, which is basically soil-coated rocks. And so it was in a trench, and it's number 2 AWG tinned copper, solid copper. And that's part of my tower grounding system. And so you can get these. They're about $8 or $9. You can get them at Gray Bar. You can get them at DX Engineering, lots of different places online. Easy to use. And you will ruin one, okay? And then you can go through and do all the rest of them. Okay, you want to bond all of your ground systems together. The cable guy, he'll come out and he'll run your cable and he'll put in a little ground rod. And the telephone guy will come out and he'll install your service box and he'll put in a little ground rod. And the electrician guys will come out and they'll put in a ground rod. And then you got your antennas and you put in another ground rod. Well, they've all got to be tied together using that number 6 AWG and the right kind of clamps, and bury that wire. So you're creating sort of a ring, a protective ring around your house. If you can get everything to come to the same point, use the same ground rods, well, that's the optimum thing, but it's not always possible. Your shack seems to be always on the other side of the house from the circuit breaker box, so you got to run a ground wire all the way back. But bond everything together. That's a must.
If you happen to have lightning rods on your house.
I do not have air terminals on my house, but if you had one up here, you'd have to run minimum number 10, and they want number 6 to a ground rod right there. Everything gets tied
It's
together.
still bonded to the same group?
Everything is bonded to the same. It's floating dock. It all comes up together. It all goes down together. Lightning protection. You can't steer lightning. It doesn't even know about you, okay? It's coming from thousands of feet up in the air, and it's going to go where it wants. So you can't really steer it, okay? But you can help it make good decisions, okay? All right. What you want is heavy, low impedance path to the earth. That's where it wants to get to. Help it get there, okay? Give it a good, solid, robust path. Inductance is really much more important than resistance here. Even a straight piece of wire, 1 foot long, has a nanohenry or so of inductance. And when you hit that thing with a kiloamp pulse that's rising in the 20 to 30 kiloamps per microsecond, that's a big change. And so your voltage is inductance times rate of change of current. So if you've got a big rate of change of current, even a little tiny nanohenry can cause that 1 foot of wire to have hundreds of volts from end to end. Hundreds of volts. So basically, inductance, you want strap, you want big wire, straight, don't coil it. Minimize your inductance by using strap, heavy wire. Paths for lightning should be outside your residence. Don't invite Mr. Lightning in, okay? Have Mr. Lightning go directly to the earth outside your house. We'll have a drawing about that in a minute. And don't make it easy for lightning to go through your station on its way to the earth. Here's your antenna system and everything's out there, and you got all your feed line cables coming in and everything, and they go through this hole. You put in a dryer vent. Ooh, cool. Comes into your station. Mr. Lightning hits something nearby. Doesn't even hit your antennas, but it induces a big surge current in the shields of those inductors. Well, it's trying to get to the earth, okay? It just goes through your shack before it gets to the ground system. Well, that's not any good because you just brought in that big current pulse right into your station. You don't want to do that. Don't make lightning go through your shack or your house on the way to the earth. Here's the drawing from the book. Okay, here's your tower. Okay, your power lines, here's your radios, you got a ground, you did your safety correctly, and you've got a ground rod out here, and you got an antenna system ground rod over here, but they're not bonded together, are they? No. So Mr. Lightning says, okay, I'm going to come down here. I'm coming over here. Well, there's a nice little connection to ground here, but hey, there's another ground connection over here. I think I'll take that one too. And when I go through there, I'm going to roast this and everything else that's close to it, okay? So this is what you do not want to do. You don't want this path. This is the path you want to get rid of. So you get rid of it, bonding. Lots of bonding, lots of ground rods outside. They're cheap. All you got to do is pound them in, okay? That's when you hire your kid or somebody, the kid, to come over and pound with one of those fence post things and pound that sucker in there. Say the lightning hits the AC power lines and comes through and it sees your ground rod, it sees this wonderful ground system here. Why would it want to go through this way? It's got a lot more inductance, it's got a lot more resistance. This is a nice, heavy, direct path to the earth. Help Mr. Lightning make good decisions as he goes toward ground. This is the way to do it, and this is why you want to bond everything together. Cable TV, telephone, data services, satellite, AC, plumbing, everything. What do you do about a tower? Okay, you're going to put up a little tower. It's like, you feel like you're just putting something there asking to get hit. Okay, generally, lightning does not hit towers very often. It'll hit a big one. It'll hit the big broadcast things. It'll hit the arch, better known as God's grounding hook. Okay, it'll hit them all the time. Doesn't really hit your towers that often. The neighbors get nervous. You get nervous. All that kind of stuff. It really doesn't do it all that often. On my hilltop down in Crawford County, I've gotten hit a couple of times. Okay, but I'm asking for it. Okay, you're not asking for it. But what do? Here's your tower. You've got your concrete tower base, all right? Take that, each leg, and connect it to a ring of buried copper, good old number 6. Just go out and buy a spool of that stuff. You're going to need it. It's not that expensive. And then at each point, you tie it to a ground rod, either with a one-shot or one of those clamps. And that generally is enough to get you started. If you really want to go the extra 10 yards, so to speak, dig a split trench, 6 inches deep or so, and bury some wire. Some more number 6, some number 2, some number 4, whatever your brother-in-law sells, from his construction business, or whatever you can get, okay? Just run it out in a radial away from the tower base. The more you can get that charge dissipated into the earth out by the tower, the less there is to come inside your house. If you talk to the cell guys with their towers and stuff, they will tell you that they get a lot of mileage out of these buried radials, okay? AM guys, AM station, broadcast stations, they have all these buried copper radials. That's great if you want to use your tower as a vertical antenna and you got buried radials or laid on top of the ground. Those are good too. Anything that allows that charge to spread out. And your radials for antennas, they don't have to be any bigger than number 18. That's fine. Make the ground ring, add your ground rods. If you want to put out radials, that's great. That's basically how you do your tower. And then there should be a connection to your station ground if you're anywhere from 50 to 200 feet from the house. Once you get beyond 200 feet or so, the inductance of that connection is too great for it to be very effective. It only is useful at AC safety frequencies.
Do you like running the number 6 up the full length of the tower as well?
No, I don't run anything up the tower. He asked, do I run the number 6 up the tower? No, I run coax up the tower. The tower's big. It wouldn't even notice a number 6 in parallel with it. Here's how you bond your feed lines to the tower. Your feed lines need to be bonded at the top and at the bottom, basically every 50 to 60 feet. If you don't bond them together, the difference, remember I talked about how much inductance and how much current can build up a big voltage spike. You can get 100,000 volts, okay, between the top and the bottom of your tower, okay? So if your feed lines are not bonded to the tower at the top and the bottom, well, there might be 100,000 volts between the feed line and the bottom of your tower. Now, I don't know about you, but I don't buy coax that can stand 100,000 volts between the inside and the outside, okay? It doesn't work. So you get one of these nice little brackets that have holes in them. They have the SO239s in them. They bolt right to your tower. You just bolt them on there, wrap them up good with tape or whatever you use to waterproof, and you're good to go. Do that at the top of your tower. Do that at the bottom of the tower. If you got a 100-footer, do it in the middle too. Yeah, you got to put on some extra connectors, or you have to strip back the jacket and put on these little clamps, and then you have to waterproof it up again. But it's worth it because you won't have to replace your feed lines. I have also seen guys put spark gaps. Say you've got an insulated tower. I've got a couple insulated towers because I use them as vertical antennas. This is from Tom, WHAI, and this is the flange on which his big tower, insulated tower sits. What this sits on is insulators, okay? But it's metal from here on up. It's a 300-foot tower on top of a mountaintop in Georgia. Do you think he gets hit by lightning? Yeah. And so you can see all he did was he put a piece of good old M-quality copper plumbing, okay, connected it to his ground system, and he bent it so that it's really, really close to the edge of the tower base. And the spark gap is 30,000 volts per inch, so that's about a couple of millimeters, and so that's a couple of 1,000-volt spark gap. You can do it with a spark plug. You can do it like I've done it at my towers. I just have spare pieces of the number 2. They just cross over like this, but they don't touch each other. They're just real close. And that keeps water and bugs from building up in the spark gap. And it'll just jump across there. A couple 1,000 volts, ground systems and gas discharge tubes, they can handle that. A full lightning strike, they can't. But lightning can jump over here, and if you look at this in color, you can see lots of little black spots where he gets hit. We talk about a single point ground panel. Now we're talking about the electricians. We're talking about what do you do? Well, okay, you want to tie everything together where it comes into your shack. Okay, you tie everything together at one single point ground panel. Now you can go out and buy a single point ground panel. You can also just put up a big piece of copper or aluminum on a piece of non-flammable backing and mount it to your foundation. Preferably this is on an exterior wall. Preferably yet it's outside, okay, so that anything bad that happens outside. You bring in all of your cables that you want to protect. Here's your telephone line, here's your antenna connector and a little antenna protector that you can buy. Here's your perimeter ground system. It goes to all of the rods around your house. And here's an AC line, okay? You run the AC line from your circuit breaker. I just run a pair, number 14, pair N0AX 14.2, run it to my single point ground panel. It's not expensive. And then I get one of these protected line duplex outlets. Isobar makes them, Trip Light makes them, Polyphaser makes them, and what they are is a bunch of MOVs and stuff that's all in a box. They have a cord on it, and you wire it up to your branch circuit, and then it protects everything that you plug into it. So that's where you plug in your power strips or your extension cords, and that's all mounted on this metal panel and connected to your ground system. So that when a ground transient comes in, this is your floating dock. Everything comes up together and it goes down together, okay? And you keep your protected cables away from the unprotected cables, okay? And inside your shack where you've got your grounding bus and everything, you connect that to this ground as well. Floating dock, everything comes up together, goes down together.
So Ward,
Yeah.
when it all comes up together,
Mhm.
and it's the shields that are all coming up together.
Pretty
do
much,
you
yeah.
not then have a strong difference potential between the center conductor and the shield?
You might, the question is, when everything comes up together and goes down together, primarily you're talking about the shields of the cable going up and down. What about the center conductors? The center conductors will follow along for the most part, but the voltage between them is, we're talking maybe hundreds of volts, not thousands of volts. The primary problem is on grounds.
So what I'm leading to is, do you, if you're going away for a week or two, do you disconnect your antenna connections to your rig?
I just make sure my insurance is up to date. Yeah, I unplug when I'm not down at the station, and I don't have it remoted right now, although I'm going to. Everything gets unplugged. You bet. And the correct way to unplug stuff is to unplug it outside, okay?
Right.
And not just unplug it, but plug it into something that's grounded.
Mm-hmm.
So if you have, don't leave it just sitting there. Have some kind of a plug, a hole. It doesn't have to be fancy. It doesn't have to be fancy connectors or anything, and then you can ground it. There are also cool little devices that when you turn off power, the relay shorts out the input to your radio, and it opens up the connection to the antenna. So that's another handy thing. It's about $100. Here's what the PLDO, the Protected Line Duplex Outlet, looks like. This is the one from Polyphaser. I think they're about $100 and something from DX Engineering. The isobars are cheaper, but they're not quite as good. I bought the isobars because I've got other stuff. Here's what an antenna protector looks like. This is from Polyphaser. You connect your feed line to this and you mount it on a grounded panel. This is another little Polyphaser gadget. This one is for rotator controllers, and you hook up you bring in your rotator controller on this side, and you hook up the control box on the other side, and that's got ground discharge tubes in it and little MOVs, and they clamp the voltage at about 100 or 200 volts. So you've got different clamping voltages for your telephone, for your cable, for your antennas, all this kind of stuff. But all this stuff mounts on your ground panel. So make the ground panel a lot bigger than you think it's going to be. Don't just make it big enough for right now, because as we all know, we never have enough radios, we never have enough antennas. We're always adding things, so you don't want to redo this. Here's a single point. Yes.
I've got a question about the
Yeah, Bill.
polyphaser.
Yeah.
If you get a lightning strike, how do you know the polyphaser is going bad?
if it's still there, it's probably okay. You can actually unscrew, most of the polyphasers have removable gas discharge tube cartridges. So if you've had a lightning storm, you want to check, you go in and you unscrew that, and you take it out and you inspect it. And if you can see burn spots, if you can see big pits in the little electrodes that are inside the glass tube, if there's nothing left but 2 wires coming up like this, then you can replace it. Okay.
You have to open up and check it out.
Yeah, you do. There's some types that will actually tell you if an MOV is compromised, but they're expensive. Yeah. This is what a single point ground panel looks like practical. Then this is during my station construction phase. I ran everything from the towers out to this pole barn type building, and I just nailed up some plywood. Yes, it's supposed to be non-flammable, but I use plywood, and then put big sheet of aluminum flashing on here, and then I mounted everything to that big grounded panel. Here's my ground wire, goes right here, pounded right into the dirt in the barn. I figure if the barn burns down, I'm good, okay? And I run hard line into these protectors right here. These are my rotator control lines. They all go to a terminal strip, and you don't see it here because it wasn't done yet, but each one of these little terminals now has a little gas discharge tube connected to it, like in this picture, yes. This is out at the base of the tower. You can see the terminal strip here, and you can see these little tiny gas discharge tubes. I just took a drill and went like that and put sheet metal screws in. That's fine. Works just great. Then they clamp at about, I think those are 150 volts on the rotator control box. This is a RCS4L from MFJ. It's the L means lightning protection, and it means it has one of these little gas discharge tubes on all 4 of the antenna lines. So my buried cable that you saw in the last picture comes up here, it goes into the switch, and then these goes out, you go out to the tower and the antennas, and they all have their little gas discharge tubes on them. So far, I haven't blown up anything except one rotator control box, and I consider that pretty good. Here's a guy, here's K4RO, and he was getting all kinds of lightning damage. He had a hilltop house near Nashville, and the storms would come through, and something would get nailed every single time. So he said, I'm tired of this. I'm going to put in this nice big single point ground panel. His shack is like up here. We're in his garage. It's above this. The shack is above the garage. So he put in this big panel. He mounted everything that goes to the outside on that panel. His antenna switches, his filters, his rotator stuff, everything. And you can see his nice big wire goes through his cinder block wall to a ground rod right outside. He hasn't lost one thing in the 2 years since he put this up. Floating dock, everything comes up together, goes down together. It's not expensive, it's just aluminum. Okay, the stuff I use is flashing. Okay, you can get a roll of it for less than 20 bucks. Inside your shack, you want to bond everything together. This drawing, a variation of this drawing has been in the handbook for years. Okay, basically, you just get a big piece of copper pipe, half-inch copper pipe. You get the right kind of clamps, ground clamps, and then you put a wire to everything in the shack. Your radio, your computer, your keyer, your antenna switch, even if it doesn't have power going to it. This goes to your SPGP, your single point grounding panel, and that also goes to your AC safety. That's all bonded together now. Everything is bonded together now. You've done one bonding operation and you solve 3 problems. That's important. You save money, you got the job done right. Okay, that's what it looks like.
Do you typically recommend a driven ground at the actual rig?
Oh, what do you mean a driven ground?
An actual
Oh, yeah.
ground through
Oh.
the floor.
Oh, well,
Say if you're in the basement.
whatever is most convenient. You know, if you've got a basement situation, you can run a wire up and, you know, out through the blocking to a ground rod. I've seen people actually drill through the floor. If you've got a sump pump or something, you can connect there. Some homes have what's called a UFA ground, or a concrete encased ground, and they actually use rebar, in it, and you can connect to that. But if you're on the second floor, you have a completely different set of problems. If you're in an apartment building, if you're in a condo, they're all kind of different. The farther you are from the physical ground, the harder it is to have an effective earth connection. And at some point, I've just counseled some people to just give up. Okay, just connect everything together in the shack. Try not to have any ground rods or ground connections that come to your shack from your antennas. I counsel people on the second floor to run all of their antennas down to the ground level, have some kind of an external panel there, do your lightning protection there, and then run protected feed lines back up the outside of the house. Maybe that can be done, maybe it can't. Otherwise, make sure your insurance is up to date and disconnect, okay? RF management. This is where we get into some serious, the black arts of ham radio. Is how do you deal with RF in your shack? You're right in the near field of your antenna. It's not very far away. Everything in your shack is part of your antenna system. Don't think that just because you ran a cable to it, you're not part of the wiring. Here's your dipole outside. It's 40 meter antenna. Okay, what's a wavelength of 40 meters? 40 meters, okay? It's 120 feet. Most city lots are not as big as 40 meters, okay? So you're in the near field of your antenna. Whether it's 100 watts, 5 watts, or a kilowatt, you're right there. Your feed line's part of it. All these jumpers between your radio and your tuner, they're part of it. All the interface cables to your PC, you are part of it when you pick up your mic cable, your power supply, your safety ground, your ground rod, your single point panel, everything. If you think about how Mr. Radio Wave looks at stuff, he looks at your shack, he just sees one big mess of wiring, and it's part of the antenna system. He's picking it up. So what do you do? What do you do with that? Everything in the station is an antenna. Just think about it that way. Forget about the RF ground. You're not going to make this go to 0 volts. Just forget it, okay? Concentrate instead on bonding. Bond everything together so it's all at the same voltage. Don't give the RF a reason to flow between your keyer and your rig through the USB cable, which causes, every time you key up, it goes until you turn the power off. Believe me, I've been there, okay? Bond everything together, short out that voltage. The voltage is what makes the current flow, okay? Equalize voltage, it eliminates hotspots. Why are hotspots always on the microphone? I don't know. It seems like everybody gets bit. This is the education of every ham. Yeah, that's right. It's right there. It's an open end, exactly, of a wire, and you're holding it, and you bring it up, and pow, you get a little RF burn. Education. All right. I know we learn from mistakes, but why do they always have to be mine? That kind of thing. By bonding everything together, for the most part, you get rid of hot spots because there are no spots, okay? Everything is connected together. It reduces RFI caused by common mode current flowing on the shields of all your different little wires. It reduces the sensitivity to physical configuration. We've all been here too. Well, I can only operate on 15 meters if I lift this piece of equipment up and I move it over here. And I can't operate on 40 unless I sit over here and kind of lean over when I use my microphone. What you're doing is changing your antenna system. Remember, everything is part of your antenna, okay? So if you don't tie it all together, everything you changes part of your antenna and the way that it interacts with that RF. So by tying it all together, you get rid of this, I can only do this if I do that kind of stuff. And it also minimizes audio buzz and hum, which is a problem if you're using AFSK to do PSK or JT65 or one of the other modes where you run low-level audio into your microphone connector. and somebody says, yeah, you got RF feedback. It's not RF feedback. What it is common mode current coming in on these various lines. And by bonding everything together, you turn off that voltage that makes that current flow. Yes, sir?
How do you bond a laptop?
Laptops. Laptops are not made to be bonded, but if you look in the back where there's a video connector generally, and you look in there, there's two little screws, and those are generally connected to the ground plane of the laptop.
If you have that kind of connector, I mean, HDMI, you don't have that.
That's right. Mostly they're not sensitive to ground. They're made to be operated just completely floating. I wouldn't tie them into the ground system unless you have a problem. Okay. One thing I have done, I'll show you this in a minute. Okay, so maybe it's real close. Hold that thought. RF management, keep your cables short. Why run 15 feet of cable, which is just going to pick up a lot of RF, when 3 feet will do? Okay, if you can keep your cable short, do it. Use a bonding bus behind the equipment, okay? And you can actually just connect all your equipment together with heavy wire if you want to, but it makes it kind of inconvenient to change the configuration. Okay. Minimize your loop area. Remember when we talked about ground loops and how the area makes a difference? The bigger the area, the more magnetic field it can pick up, okay? So minimize the area. Twist the wires together, for example. You can cut out a tremendous amount of audio entertainment system, speaker-driven EMI, by using twisted pair cable. Just take your speaker wires and twist them together so that they have 1 or 2 twists per inch. That balances them and it minimizes the loop area. So just keep your cables together, run them along the ground connection.
Any benefit to using heavier shielded cables?
Do you need to use heavier shielding? It really doesn't matter unless you've got a lot of current going through it. And in your shack, even one of those little Mission Impossible clips is probably enough. But if you really have AC leakage cable, leakage current going through, or if you're running an amp, you would want to use number 14 or number 12. Here's what I do, and it's very inexpensive. I used Costco tables at the station down in Crawford, and so what I did was I got a piece of aluminum flashing. It's 12 inches wide. Just got a roll of it from the store. I bent it over one end of the table right here, ran it along the table, and just used sheet metal screws every so often to hold it down. And then bent it over at the other end with more sheet metal screws back there. Do not do this on an heirloom oak table. Don't ask me how I know that. No. It's easy. All you have to do is punch a little hole through. Works great. And then I laid the piece of copper pipe on top of it, used copper clamps, connecting it to the flashing, and then I just went through and drilled a bunch of holes and put sheet metal screws in that pipe. And this is, if you're just starting out, this is the perfect time to do it. You can do it on shelves or tables or whatever. You haven't got your equipment all bought and piled up there, and you have to take it all off first and put it all back on. So you're just the right time to do this. And then you use little short jumpers between the radio's ground terminal, and they all have a ground terminal, and you connect that to your bus. Okay, helps keep the voltage the same, because when that RF field comes in, and here comes the wave, what does it see? It sees this big, flat, low inductance connector, and basically it just kind of shorts out all of the electric field. It says it's all going to be at the same voltage. So I lay all of my little cables right on that ground plane, and that minimizes the amount of RF that can get to them. And then that's bonded to my station ground. Here's the big wire right here with the great big terminal. Okay, good news. One system to rule them all, okay? At one ground system. Oh, and I forgot. Let me back up one more. When you do a laptop, you can kind of see right up here, I found a terminal on my desktop system. And you have to hunt for these because they don't make them easy to find now. It used to be everything was metal, and you had all these connections. When you hook up your desktop or your laptop, if you want to hook it up to this ground system, you've got to find some kind of a connection to the ground plane of your computer. Typically, the best place to do that is at the video connector. If you've got a video connector with screws on it. HDMI, you don't. But HDMI is a very high-speed serial connection, and it's typically not susceptible to RFI, nor does it cause RFI very much. The nice thing is we've got signals that are so high in frequency, they're above the ham bands now, so we really don't have too many problems with that. Find some metal on your laptop or your desktop and connect it to this with a short jumper. Most laptops, though, are not designed to be grounded, and you really don't need to ground them. They can float. What you need to worry about is your cables. Keep them short, coil them up, lay them on the ground plane. I saw a hand back there.
The screws that hold your power supply and your desktop are always guaranteed grounding.
What?
The screws that hold your power supply and
Oh, yeah.
those are guaranteed grounding.
Yep, that's good.
Very convenient.
Those are typically right on the inside of the IEC connector, and they go around like this. The only problem you can have with those is sometimes they have a nut on the inside. And so you loosen them up a half a turn, and that's as far as you get. So you have to find a sheet metal, or you have to take the enclosure off. But whatever, that's...
By code, they can't do that anymore. They've got these sprouts.
Really?
Yep.
Yes. Okay. Well, that's good. He says, look for where your power supply is on your desktop. Those are going to be the grounding screws. Okay. Okay. By making one system, you solve your AC safety problem, you mitigate your lightning protection, and you mitigate your RF pickup problems. One system done one time right solves all three problems. And just remember, all currents flow on all wires. It's not like you've got a 60 hertz current and it comes up to your ground system and goes, wait a minute, I'm an AC current. I have to flow on the green wire, so I got to go over here. It goes anywhere at once. Ohm's law is all that counts. Mr. Lightning will go anywhere and everywhere. RF will go anywhere and everywhere. So make sure all your wires are connected into this one system. A single solid ground system made of short, heavy direct connections satisfies all of the requirements, all of them at once. So if you do it right once and you maintain that system, you solve all of your problems. It'll never give you any extra grief, okay, unless you take it apart. Why would you want to do that? I don't know. Build it in once, go through the trouble, build your station around it, and it will keep you out of trouble. This is sort of a schematic of what it looks like. Here's your tower. It's got its little grounding kit. Here's the ground rods. It's got the big bonding thing. Goes back. Here's your ground rod to your AC power panel. Then you got your perimeter ground. It goes all the way around the building or most of the building, whatever. All of your external grounds are connected together. Here's your single point grounding panel. If it can be right next to the AC ground panel, terrific. If it can't, do what you can. Tie everything into it as much as possible. Okay. Run your AC line over there to that PLDO, which goes on here. Here's your ham radio equipment. Here's that bonding bus that we just showed. And that big ground connection goes to your single point ground panel. Single point ground panel is tied to your perimeter ground. So your phone system, your cable system is protected. Your AC ground that goes to your ham radio equipment is protected. That's pretty good. If you read Ron Block's articles from QST in 2002, he talks about establishing a protected zone, and he walks you right through how to do this. Your entire house, or maybe just your living room, or whatever you want to protect. He talks about how to make sure that you've established the zone of protection and what to do to protect your stuff.
Or
Yeah.
does the perimeter ground in that diagram go all the way around the house?
If possible.
Some idiot put a driveway on one side of my house, so it makes it a little hard to bury anything there.
Yeah, I got the same problem.
You know,
It's not important that it be a complete ring. If you are building a new house or whatever, sure, put in a ring. If you can't, just stop at the driveway and just go all the way around. That's the way it is with my house in Crawford.
So it's like a C shape, basically.
Yeah, yeah, that's fine. You're just trying to establish a big, solid, buried piece of copper so that when anything comes in that you don't want, you've given it a terrific, short, low inductance, low resistance path to the earth.
How deep do you bury the copper wire that's running underground around the house?
Anywhere from 6 to 18 inches, whatever you can put up with. You can just kind of dig a shallow trench and throw some dirt over it if you want. Some people will get a ditch witch out and do the whole thing.
Cut the phone lines, cut the cable lines.
Yeah, right. Then you cut every wire that's out there. You can use an edger, whatever. This is when you find out all the buried things. And before you start digging, call 811. Okay. And they'll set up an appointment, they'll come out, and they'll trace everything that goes through your yard. And you'll be amazed. I had no idea. My phone line, I thought it went, over here. It doesn't go over here, it goes this way. Why, I don't know. But it does. So now I know where that is. And it's free. No, you just have to wait for a couple of days. Okay, we're about done. Inside your shack, here's the service panel, here's your SPGP, here's your protected outlet, and everything ties back to that. Here's your grounding bus, here's your AC safety ground, it goes back. Here's your bonding jumper, here's your ground electrode. Bond. It's not like I bought futures in copper so I could come here and tell you guys to go down and buy stuff, but it really does work. Here's your additional resources. The professional associations are all anxious to get this information to you, and they all have excellent stuff for consumer people, not just electricians, but the layperson. National Fire Protection Association, they do the National Electrical Code. They have lots of links on their site. International Association of Electrical Inspectors, another good source. Mike Holt Enterprises, he's really good. He has a site that specializes in training electricians, electrician assistants, journeymen, and apprentices, and all this kind of stuff. There's lots of tutorials and training stuff on his site. Polyphaser has lots and lots and lots of white papers. Google is your friend on this. You just have to kind of make some serious little notes here. Various papers, tutorials on lightning protections, including ham stations. And the Lightning Protection Institute, I guess you can tell what they're about. Papers and tutorials on lightning protection techniques. Here are the standards. If you really want to cowboy up and get some serious education, FAA document from 1999, I think, on grounding, bonding, and shielding. IEEE standard. This is a expensive thing to buy, but you can get it through the library. And Mill Handbook 419. Grounding, bonding, and shielding for electronic equipment. You want volume 1 on that. And this is available online for free. This is available online for free. The IEEE is not. IEEE also has a lightning protection for your home. Go to the ARL website, go into the Technology Information Service, search the safety page. There's all sorts of good stuff there for free.
Can you go back to the previous page?
Sure.
Shoot a picture of it.
This one?
Yeah, the one with all the different references.
Okay. Tell me when.
I think I got it.
Okay, yeah, all right. Additional resources. There's a book called The Grounds by the same Block brothers that wrote the QST article. There's Lightning Protection and Grounding Solution for Communication Sites written by Polyphaser. Here's your ARL websites right here. Electrical safety, grounding, lightning protection. And W8JI is the guy that lives on the has the 300-foot tower on the top of the mountain in Georgia. His site's full of good stuff, okay? He has lots of electronics up there. Are we done yet? Yes, we're done yet. So thanks very much. I'd be happy to answer questions after the show. Thanks for your attention.